homework this week for concrete, also for steel. Be prepared for your exam on Friday.
That is fun.
We will talk about something called serviceability limit state for according to ACI. Actually, your design using limit state can be divided into two parts. We covered this before, I think. We have something called strength limit state. We have something called serviceability limit state. I'm sorry, what you mean? Strength limit state, everything we covered before. Strength limit state deals with design, safety of structure under factored load. We have something called P ultimate. We have something called your design strength. And this value must be smaller than or equal this value. If you are talking about design, how much steel reinforcement, what is the dimension of your concrete, all of this stuff, you are talking about strength limit state. We have another type which called serviceability limit state, which deals with performance of structure under surface load. This one is very important. If you are talking about strength limit state, if you would like to design, go ahead and get your factored load. What do you mean by factored load? I mean, if you are talking about dead load only, 1.4 dead load. If you are talking about dead and live, 1.2 dead load plus 1.6 live load. If you are talking about dead and live and wind, if you are talking about dead and live and earthquake, all of this stuff, all of combination we did before. If you multiply your value of load by a factor, this value called factored load. We need this value if you are talking about strength limit state, if you are talking about design, if you are talking about safety of your structure. But if you are talking about serviceability limit state, if you are talking about performance of your structure under load, we are talking about something else, which called surface load. What do you mean by surface load? Just dead load alone. Just dead load plus live load alone, without any factor. So your load without any factor can be called surface load. We are going to use these values for serviceability limit state. Okay, what do you mean by serviceability? Examples of serviceability, we need to ensure your deflection of your structure within the limit. Your cracking in your structure within the limit. Your vibration, sometimes your structure is safe. Perfect. Nothing wrong in your structure. But if you have a machine and you turn it on the machine, something will happen in your structure. It's still safe, but you are feeling something wrong about vibration on the building. This called serviceability. Remember, all of this stuff, I don't care about them regarding your design. Your design is safe. Nothing will happen, no collapse will happen. But when you are using your structure, you are not feeling good. Something not good about your structure, maybe your deflection. Your floor is good, is safe. Nothing will happen, no collapse. But you have some curve in your floor. Your floor looks like what head? It's curved, or you have excessive deflection in your structure, but your structure is still safe. Cracking in this wall, you found crack in this part, but your structure is safe, but these cracks will make you uncomfortable. Vibration or surface corrosion or something in your structure. So actually, I will talk about deflection and the cracking related to your structure. Let's see. For deflection, we have two types of deflection. The first type, we have a concern about the first type, which called short-term deflection. The second one, long-term deflection. We talked about long-term deflection before. Anybody remember the effect of shrinkage and the creep of the material of concrete? For example, creep means, do you remember creep?
Yeah.
Yeah, your load is constant, but with the time, your deflection increase. Your deflection increase. 2 years, 5 years, 20 years, 30 years, your load is the same, but your deflection is still increase. This is called long-term deflection. We will focus on the first one, short-term deflection, means the immediate deflection after casting and application of partial or full surface load. Once you put your load, dead load or live load, you have a deflection in your building. This deflection called short-term deflection must be smaller than or equal your allowable. What is the permissible or allowable deflection? According to ACI, if you are talking about floors or roofs, your immediate deflection must be, if you are talking about live load only, your immediate deflection must be L over 360. The maximum deflection, if you are talking about roof live load or snow load or rainfall load, your immediate deflection, maximum immediate deflection must be L over 180. I'm sorry. What do you mean by L? You have a beam. From a structural analysis, your load using double integration or virtual work, your beam will deflect by a value equal y, and you have slope rotation equal theta. Maximum deflection for this beam, something near your midspan, y maximum. So y maximum, or I can call it delta maximum, which called maximum deflection from structure analysis, from your external load. This value must be smaller than or equal delta allowable or delta permissible. In this case, most of the time we are using this value because we are talking about live load for floors. Your value is L over 360. That's right?
Yeah.
Yes. What is the mean of L? Total length of your beam. Total length of your beam. If you have reinforced concrete beam and you put your load and you have a deflection, your maximum deflection near midspan most of the time, your maximum deflection must be within the limit. The limit equal your span over 360 based on ACI. So after you are done with your design, your steel reinforcement is okay. Your stirrups are okay against shear. Nothing related to your torsion. Everything is good. You did your design. Please go ahead and check your deflection. Your deflection must be within the allowable. Any question? We have different values, but in different situations. But the most situation is your span divided by 360 against live load only. And remember, if you are talking about your load for serviceability, we are talking about surface load without any factor. Just your live load as a value without any factor. Any question? So next time we will solve this slab on RISA, and I will let you know how to get your deflection. Your maximum deflection for this floor, I think, will be at the middle. Once you get your deflection, compare this value by L over 360. Which L for this area?
The lane.
This one or this one?
The longest.
The smallest one.
The smallest.
Smallest one will give you more restricted deflection. If you have area 10 feet room like this, 10 feet times 20 feet. So we have two values, 10 divide 360 or 20 divide 360. Which one will be more conservative? This one. So I will compare my deflection from structure analysis or from RISA or from whatever by this value. The shortest distance of your area divided by 360. This for slab. I'm talking about slab. If you are talking about beam, we have only one distance or one span, your L. But if you are talking about floor, so we are talking about area. So we have longer and we have shorter distance. Maybe both of them are equal. Anyway. Okay, so keep this one in your mind. L over 360, we will use it later. Against life load, and your life load is surface life load. The second one, I would like to talk about this point, and you can expect one question in your exam. Just diagrams. Maybe you need to draw or you need to figure it out. If you have a reinforced concrete beam, we have a reinforced concrete beam, maybe this area, and you saw some cracks in your beam, can you judge, hey, these cracks due to shortage in stirrups, shortage in longitudinal bars, we have issue with bending moment, no, we have issue with shear, we have issue with torsion, you know what I mean?
Mm-hmm.
I would like to judge if you see some cracks in your beam. Based on the shape of your cracks, location of your cracks, you can tell me, hey, we have issue in this beam related to what? If you have cracks with 45 degree inclined cracks, so your orientation of your cracks inclined, not vertical crack, not horizontal, inclined cracks near your column. We have a column here, we have another column here. Your cracks near your column with 45 degree, these cracks due to shear. We don't have enough stirrups to support your shear. If you have a beam, reinforced concrete beam, and you found this kind of cracks, first, near supports. Second, inclined cracks with 45 degree. These cracks, because you didn't provide enough stirrups. You didn't provide enough shear reinforcement at this location and this location. Two conditions. Your cracks near support, your cracks, inclined cracks was 45 degree. Almost 45 degree. Second type of crack. This one, let's start with this one. We have vertical cracks. These cracks are vertical cracks. So the first one, we don't have enough stirrups at this location. We don't have enough stirrups, which called transverse reinforcement. We can call it shear reinforcement for this beam. Second one, you have vertical cracks, vertical, not inclined. Mostly vertical cracks at or near midspan. At the midspan of your beam or near your midspan. These cracks called flexural crack or bending cracks. We don't have enough steel reinforcement in your beam. When you designed your beam, you didn't provide enough reinforcement to support your moment on this beam, M ultimate. Your design bending moment and you require bending moment, this one must be smaller than or equal this one, but this not happen. You can expect cracks like this. Vertical crack at midspan of your reinforced concrete beam. Third one, if you have horizontal crack at the lower part of your beam, if you have horizontal cracks, if you have beam and you found horizontal crack at the bottom part of your beam, these cracks maybe you have a corrosion in your steel reinforcement. Maybe your beam is 50 years ago, so we can expect corrosion in the reinforcement embedded. This corrosion will make this type of crack. Or you didn't provide enough concrete cover. As you remember, we have something here called cover. That's right? This cover something around 1.5 to 2.5 inch. If you did not provide this enough cover, you can expect this shape of cracks. Actually, if you can find these cracks, we have another steps how to solve this issue without removing the structure. No, you can solve this issue, but we don't have time to cover all this stuff. Anyway, so horizontal cracks at the bottom part of your beam due to corrosion of steel reinforcement or insufficient concrete cover. The third one, or the last one, if you have crushing at the top part of your beam and this crushing extended to down like this, that means we have crushing failure or compression failure in concrete. You have crushing failure at midspan in this area. You will find your concrete crashed. Any question?